Bitcoin and other applications of blockchain. Chunk 2. Professor Massimiliano Sala, University of Trento. Introduction, Cryptocurrencies. In this chunk, we will introduce cryptocurrencies and their desirable properties, such as decentralization, anonymity, avoidance of double spending. We will construct some toy cryptocurrencies, and we will examine their strong and weak points in order to emphasize some common issues. So, what are cryptocurrencies? They are currencies that are completely digital. There is no physical money, such as coins and paper money, differently from what happens, for example, for euros and dollars. There are possible alternatives to fiat currencies, since they can be used for paying goods or services, send money to people or organizations, but they can also be exchanged with other currencies, bought and sold. Why are they called cryptocurrencies? The trust in the exchange of these currencies is based on cryptography, rather than on legal entities such as central banks or payment circuits. Indeed, in order to work properly, all currency must have a way to check the provision and some security method to avoid frauds. In the context of fiat currencies, banks check the amount of money and provide some physical anti-fraud methods, such as the watermark. In cryptocurrency, there are no banks and everything is done using cryptographic methods. We introduce now a first simple cryptocurrency. Suppose that Alice and Bob want to design a new currency that does not require any bank or central authority of any kind. They prefer to trust cryptography rather than any human organization. In this case, they need to face two problems. They need to find a way to create the digital coin, to issue a coin, and a way to transfer it. We assume for now that Alice and Bob are very good friends and they do not cheat. Alice could create a text file with the written content coin 1 by Alice. In this way, one Alice coin is issued. Then she can send the file to Bob, and so one Alice coin is transferred. The same can be done by Bob, who creates coin 1 by Bob and send it to Alice. The first problem here is that Bob cannot be really sure that it was Alice to send Alice coin. To solve this problem, Alice and Bob meet face to face and exchange cryptographic keys. When they meet, Alice gives Bob her public key and Bob gives Alice his. Then, when Alice wants to issue coin 2 by Alice, she will sign the file with her private key. Bob can then easily check the file's authenticity by using Alice's public key. Summarizing what explained so far, a file coin 1 by Alice is no more than a piece of paper. It has no value since it's not possible to guarantee that Alice sent it. On the other hand, if Alice signs her file coin1 by Alice, she gets a valuable coin, being able to guarantee its origin. So the very basic need for a cryptocurrency is the use of a digital signature function. For example, in the Bitcoin system, people use ECDSA as digital signature. This simple cryptocurrency works properly for two old friends, like Alice and Bob, who do not cheat. But a problem arises if they start giving their coins to other people who are not trusted. For example, now we allow Eddie and some other people to enter the system. If Eddie receives coin1 by Alice, signed from Alice with a valid transaction, Eddie could copy it, thereby issuing new Alice coin without the authority to do so, and send it to many different people. These are invalid transactions. All the recipients will believe the file is a valid digital coin issued by Alice, provided they know her public key. How can we prevent Eddie's bad behavior in this case? Well, a way to prevent malicious copies is to force Eddie to notify the other participants when performing transactions. He could, for example, sign a file containing the following information. Eddie transfers coin1 by Alice, signed by Alice, to John, and then send it to everyone. Let us call this a notification. Another problem arises. How can anyone be sure to have received all the notifications? The solution is to hash the set of all notifications sent by everyone and broadcast the hash itself. Indeed, if, for example, Alice misses a notification, the hash of the notification she knows and the received hash will not match. The basic cryptocurrency we explained suffers still from several limitations. First of all, everybody have to trust the coin's issuers. Second, everybody has to meet in person to change public keys. Third, everybody have to hash the set of all notifications very often to check to be in sync with the system. Is it possible to solve them? Well, we'll try to construct another cryptocurrency using hashes in a more clever way. Observe. Is it really necessary to meet in person to change public keys? No. Alice and Bob and the other participants do not really need to know each other. They can use public keys directly as identities. The knowledge of the private key is then all what is required to prove an identity. However, public keys are large, so the participants can use the hash of their public key as a digital identity. Moreover, this hash looks random, so the real identity is safe. So, in order to control a transaction claimed as yours, one needs to check that the public key used in the transaction indeed hashes to your identity. Also, that the signature contained in the transaction can be verified with your public key. So there is no need of a central authority to which you register. You can register as a user by yourself. Anytime you want a new identity, which is just a hash of a public key, you can generate it. So we can construct a cryptocurrency that obeys only 3 rules. First, any participant has an address as identity, which is the hash of his or public key. Second, a special entity, Alice, can issue new coins belonging to her whenever she wants. She generates a new coin ID, constructs a string with this ID, and signs it by means of her secret key. In other words, the coin is just the pair string signature. Then, Alice, having issued the coin, is its owner and can transfer the coin to someone else. For the transfer, we have to be careful. Alice creates a statement, pay age to BoAB, where age is a link, technically called hash pointer, referring to the coin created by Alice and proving its validity, while BoAB is identified with his address. Then she signs the string representing this statement, obtaining a valid transaction. So now BoAB owns the coin. He can prove this, since Alice's signature is valid, and BoAB's coin has a link to a valid coin that was validly owned by Alice. In the same way, BoAB can now create a valid transaction and pay with that coin. The system we have implemented so far solves many problems, but it still suffers from the so-called double spending attack. In fact, BoAB can pay both Eddie and Dan with the same coin. Both Eddie and Dan can correctly claim to be its owner. We need yet another cryptocurrency, more complicated in terms of data structures, to avoid the double spending attack. Okay, in this new cryptocurrency, a unique special entity, Queen, publishes all the transactions happened so far, but divided into blocks, each block having a link to the previous one. The link is made using hash functions, and that's the hash pointer. Now, this set of blocks forms collectively a blockchain, and it's digitally signed by Queen. More precisely, any transaction in each block contains the transaction ID, the transaction contents, and a link to the previous block. Queen digitally signs the final hash pointer, representing the entire structure, and publishes the signature along with the blockchain. This way, a transaction is valid if and only if it has been signed by Queen, if and only if it is in the blockchain. There are 2 possible types of transaction in this system, as usual. Create coins, which correspond to issuing, and pay coins, which correspond to money transfer. With create coins, it is possible to create more than one coin at the same time, and each of them has a serial number and a value. In this transaction, these coins are given to Queen herself. Pay coins destroys some coins and creates new coins of the same total value, which might belong to different people. This transaction has to be signed by the owner of the coins. So pay coins is valid if and only if the coins involved in the transaction are valid. No double spending happen, which can be checked by looking at the blockchain. The total value of the coins coming out of the transaction is equal to the total value of the coins that went in, and if the transaction is validly signed by the owners of the coin. We give now some comments of this cryptocurrency. Anonymity? What about anonymity? It seems anonymous, but not really. Indeed, your identity is a pseudo-random number, but it performs some action. And it's possible to connect actions and discover something about your real-life identity. For example, what you buy, when you buy, where you buy it. On the other hand, in this cryptocurrency, everyone can check the validity of coins, so no counterfeit coins here, and double spending is avoided. But the real price to pay is that Queen is too important. She cannot create false transactions, but she can decide to stop transactions from someone, just not inserting them into the blockchain. She can also disrupt the service according to her whim. We are ready to summarize what we found so far. Cryptocurrencies are completely digital currency without physical money. They are decentralized, so they do not need a central authority in principle. They are based on cryptography and most of all on hash function. It is desirable for them to be anonymous, and so identities can be represented by hashes of public keys. Hashes do not allow anyone to make copies of existing coins, and double spending can also be avoided.